Welcome friends to Quick Algebra Problem Solving. This is Atanu Chaudhary of SureSolv. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SSC CGL Solution Set 51 on Algebra 12 from SureSolv.com. Let's solve the first problem. Have a close look at the problem and analyze it. All the terms of the numerator and denominator of the target expression are same, except one pair of terms differing in sign. This is the ideal form for applying the powerful componendo dividendo method. To apply this method for evaluating the target expression, you need to evaluate b by a from the given expression, and that you get as b by a equal to 1.50 divided by 0.04 equal to 75 by 2. By componendo dividendo method, subtract 1 from b by a, next add 1 to it, and then divide the first result by the second to get b minus a divided by b plus a equal to 75 minus 2 divided by 75 plus 2 equal to 73 by 77. Answer is option A, 73 by 77. A quick solution in mind. Let's solve the next problem. Analyze the problem for the quickest solution. In this case, with just a look at the given expression, you have spotted the missing elements. Yes, you are right. A minus b is missing from the first denominator, b minus c from the second, and c minus a from the third. Introduce these elements straight away and make all three denominators equal to a minus b multiplied by b minus c multiplied by c minus a. With equal denominators, you can now add up the numerators and get a minus b whole cube plus b minus c whole cube plus c minus a whole cube. A lot you have achieved in this first stage, but you have also discovered the second important pattern, that is, the sum of a minus b, b minus c and c minus a is 0. For ease of manipulation now, introduce the dummy variables for the substitutions p equal to a minus b, q equal to b minus c and r equal to c minus a, so that the target expression is changed to a simple form of p cube plus q cube plus r cube divided by pqr with p plus q plus r equal to 0. This is target expression transformation as well as problem transformation. The problem is changed to a much simpler form. We do not need to use the variables a, b or c anymore. Now apply the three variable zero sum principle. You have p plus q plus r equal to 0, or p plus q equal to minus r, or p cube plus q cube plus 3p cube multiplied by p plus q equal to minus r cube. So p cube plus q cube plus r cube equal to 3pqr. You have replaced p plus q with minus r and transferred it to the RHS, and shifting minus r cube to the LHS. The target expression value is simply 3pqr divided by pqr equal to 3. Answer is option B, 3. By applying the concepts and techniques, you could solve the problem easily in mind. Let's solve the next problem. Have a look at the problem and try to find the solution. You may immediately spot the key pattern of square root 12 equal to 2 root 3 and square root 147 equal to 7 root 3. So you add up the two RHS terms to get 9 root x equal to 2 root 3 plus 7 root 3 equal to 9 root 3. So x equal to 3. Once you discover the key pattern, solution comes quickly. But if you do not discover the pattern, from the simple integer choice values, you would be certain that the two terms could be combined. With this certainty, you would surely be able to discover the pattern. Answer in this case is option C, 3. Let us solve the next problem. This is an algebraic ratio problem where you have to use the basic ratio concepts and algebraic concepts. Identify the key indicator that the first terms of the numerator and denominator of the target ratio are MP and MQ. That is, coefficients for both P and Q are same. So you take the common sense path by expressing P in terms of Q from the given ratio relation to get P equal to 2 by 3 Q. You know that when you substitute the value of P in the target expression, the first term of the numerator will change to 2 by 3 MQ. The same will happen when you substitute R equal to 2 by 3 S and T equal to 2 by 3 U. The target ratio will be changed to 2 by 3 of MQ plus NS plus OU is to MQ plus NS plus OU. Equal to 2:3. Answer is option A, 2:3. Let's solve the last problem. Analyze to have a feel of the problem. After a few moments, you have decided straightway that deriving the value of the target expression from the given expression by deductive steps won't be feasible. But then how to proceed? At least you know, because of the perfectly symmetric nature of the LHS in variables A, B and C, these values must be same. Trying out equal values of A, B and C that would result in RHS value of 2, you may intuitively identify half to be the value for each of the variables. That would give 2 on the RHS, and so the answer would be 3 by 4. Like 1 by half plus 1 plus 1 by half plus 1 plus 1 by half plus 1 equal to 2 by 3 plus 2 by 3 plus 2 by 3 equal to 2, and A square plus B square plus C square equal to 1 by 4 plus 1 by 4 plus 1 by 4 equal to 3 by 4. But that is intuitive, which is uncertain. You may also proceed in a more certain way without depending on any chances. This would be a new approach of trying out which choice value can satisfy the perfectly balanced and symmetric sum of squares A square plus B square plus C square, as well as satisfy the given expression. To satisfy the given equation, the values of A, B and C cannot be searched, and so the values 1 by 3 for option B and 4 by 3 for option D are immediately considered as invalid for A square plus B square plus C square. Because of symmetry of both LHS of given expression and the target expression, you already decided that the values of A, B and C must be equal. 27 by 16 can be a candidate for answer with A equal to B equal to C equal to 3 by 4, but this would violate the given equation. 1 by 3 by 4 plus 1 plus 1 by 3 by 4 plus 1 plus 1 by 3 by 4 plus 1 is not equal to 2. The last choice value of 3 by 4 satisfies the requirements of both target and the given expressions. You have used working backwards approach with verification from the given conditions, a mathematically sound and assured path to the solution. Answer is option A, 3 by 4. To read the detailed solutions, refer to the corresponding article in our website SureSolv.com. Link is in the description of this video. Thanks for watching.